All right, so one thing that we're going to talk about today is the angle-side relationships within a triangle. So although we can't, in this course, we don't have enough knowledge to use sides to figure out angles and use angles to figure out sides right now, what we do know is that the longest side of a triangle and the largest angle in a triangle will always be opposite from one another. So when and then that's also true for the shortest side and the smallest angle. They will also be opposite one another. And so anytime you have two congruent sides, they're the same size, right? Then the two angles that are across from those sides will also be congruent. So let's take a look at this triangle right here. This triangle asks us to figure out which angle has the smallest measure, but they didn't give us any of the angles. Now I can't figure out what the actual measures of the angle are, but I can figure out which is the smallest and which is the biggest. So I'm going to go ahead and just label, here's my largest side. So that means that this is my largest angle. Here's my medium-sized side. That means that this is my medium-sized angle. And this is my smallest side, which means that this is my smallest angle. So notice how the largest across the large, the medium is across the medium, the small is across the small. Now, it does not mean that the angle is 5 degrees. It just means that this is the smallest of the three angles. So this one asked us which is the smallest angle. So we're going to say that angle B is the smallest. And to justify, we want to explain this property. So the smallest angle will be opposite the smallest side, and the smallest side is segment AC. Notice my really good notation here using the segment bar, not just saying AC without it, because AC without it means distance, not segment. And so there's my justification. And here is my evidence, right? I labeled this and there's my evidence. Now, this is a throwback question. Is this triangle a right triangle? Now, the only way that initially we might be thinking is, do we know if any of these are 90 degrees? But if I look at these, we don't know what any of these angle measures are. All we know is that we have a small, a medium, and a large. But what we do know is that if this were a right angle, the right angle has to be across from the hypotenuse, the longest side. So if this were a right angle, this would have to be our right angle, this would have to be our hypotenuse, and then these would be our two legs. So what I can do is I can check. The Pythagorean theorem only works for right triangles. So I can see, do these three sides work in the Pythagorean theorem? So I'm going to plug in the two smaller side for my two legs and the largest side for my possible hypotenuse, because if this were a right triangle, my largest side would have to be the hypotenuse. So I'm putting a question mark over this equal sign because I'm not actually sure if this is true. I just want to check and see, is this true? And what I get on the left side is 125, and on the right side I get 144. So this actually tells us that that is in fact not true. So now there's my evidence, and I need to put my claim. No, triangle ABC is not a right triangle. And my justification explains that the Pythagorean theorem only works for right triangles and it did not work for this triangle. So there's my quality justification here. Okay, so let's go ahead and practice doing the same idea that we did right here in reverse. I'm going to encourage you to pause the screen and try question 3, and then only play it when you're ready to check your answer. So when I take a look at this problem, the first thing I'd like to do is I know 2 angles. I know all 3 angles need to add up to 180 degrees. So I'm going to find out what the last angle is. And when I subtract, I get that that last angle is 46 degrees. So now that I know that this is 46 degrees over here, now I can tell what's my smallest and largest side. This asks us which side is shortest. Well, we know the shortest side is going to be across from the smallest angle. So here's my smallest angle. So that means that this has to be my smallest side. So I'm going to explain. So side DF, so segment DF with my good notation, is the shortest side. And then I'm going to explain why. The shortest side is always across from the smallest angle, and angle E is the smallest angle. All right. Now, let's think about our right triangle. I'm going to, again, encourage you to pause this, take a moment, think about it, and then come back to it when you're ready to check your answer. So this says, given a right triangle with these 2 legs, so because they both have A, sorry about the bell, I'm going to notice that this right angle has to be at A, because my 2 legs are the 2 sides that make the right angle. So this has to be AB and AC, right? Those 2 segments. And so then I see my hypotenuse would be the 3rd side, CB. So it asks which angle has the largest measure. Well, I know that angle A has to be the right angle if segments AB and segments AC are the legs. And if there's a 90-degree angle and the 3 angles have to add up to 180, there's no way that there could be any angle larger than 90. In fact, we couldn't even have another angle equal to 90, because then that would leave 0 degrees for the 3rd angle, which would mean we wouldn't really have a triangle. So one way to justify it is 90 is going to have to be the largest angle. Now another way is to justify it with our new rule. The largest side of a right triangle is the hypotenuse. Here's our largest side, and our largest angle is going to be across from it. So here's our largest angle. So I think that way is going to be easier to explain. And so I'm going to explain it that way. So segment CB must be the hypotenuse, which is the longest side. The largest angle is always across the largest side. So angle A must be the largest angle. All right, we're going to take a look at just one more. So in this example, again, I'm going to encourage you, pause this, try this problem out, set up an equation to solve for x, and then don't come back until you're ready to check it. So when I take a look at this, the angle measures are all labeled. So one thing I do know is that the angles in a triangle all add up to make 360 degrees. So, sorry, not 360, 180 degrees in a triangle. So I'm going to add these all up. 133 minus 3x plus my second angle, x plus 39, plus my third angle, 5x minus 52. Together, those 3 angles have to make 180 degrees. So I can use this to solve for x. So I'm going to combine my like terms. So negative 3x, x, and 5x together, that makes 3x. And then I am going to add up 133, 39, and 52, and that is 120. And so I'm going to solve for x, and I get x has to equal 20. Now that I know what x is, I'm going to substitute x in for each of these angles. Now, this time I need to know all of the angles so that I can know which is the largest. So when I substitute it in, 133 minus 3 times 20, that gives me 73 degrees. When I substitute it here, 20 plus 39, that gives me 59 degrees. And 5 times 20 minus 52, that gives me 48 degrees. So what I'm going to do now is I'm going to say, okay, I'm trying to figure out which segment is longest. Well, which angle is the largest? This is my largest angle, so this needs to be my longest side. So now I just need to justify. I'm going to use my good notation. Segment AC is the longest. The longest side is across or opposite from the largest angle. And angle B is the largest angle. Notice on every one of these problems, I have my evidence, I have my claim, and I have my reasoning that states the rule that connects why did my evidence make me choose my claim. So this reasoning should explain the definition that connects my answer, which is longest, to all of the work I did. All right, at this point, you are going to go ahead and skip question 6. And you are going to give question 7 a try, and you're going to go on from there, starting with question 7, and then you're going to practice some of your angle relationships in the following problems. Have a great day.